Mentally math.
Let's get mental!
All right. Well, you just get on with your bad selves then. I'll catch up soon. By the way, let's get where we can actually see it a little bit better. Anyway, it's negative 10 to the power of 2 plus negative 10 to the power of 3. You want a normal number when you end up at the end. Normal number, not an exponent. Relatively normal number. Natural. Oh, natural might not be the right word. Exactly, because, negative sheet. Negative sheet. Bad! Okay. Oh, we are recording, aren't we? Okay. So.
Mr. Brecker, Adrian has a question.
Huh?
No, it's just that it's very hot.
I know,
Extremely. It's very hot in D. Wait, where would you be?
Yeah, that's
Ouch. Yes.
Yeah, it is very. That's like,
Well, maybe that is the temperature of some water that someone's making.
Yeah, that's
Okay.
Why don't we say that?
If someone was swimming in there.
No. Maybe it's a hot tub. I don't know. Okay, well, sounds like people are out ahead of me. I'll get started then. Okay, so this would be positive 100. And then this, of course, would be negative 1,000, getting us to a value of negative 900. Then here we can say, remember though, we're dividing. Uh-oh. That get anybody? Really? Oh, I thought it might.
Mr. Factory, I'm so sorry for you.
I thought it might. I thought people might get tricked into thinking it was times. So. Okay, well, this seems pretty simple. Ta-da! Oh, but also don't forget. Aha. Or if you're feeling Khan Academy E.
Khan Academy.
Plus or minus 10.
Mr. Pressure, did you get any joy for some people forgetting that 10 and negative 10?
It's moving along. Alright, so looking at this, I can think, well, it's 5 times 18, or I can break that up into thinking I've got my 50, and then I've got 8 times 5 is 40, so 50 plus 40 is 90. 90 plus 32 is
122.
Oh, God. Yeah, that's what I'm saying. That's what I said.
okay, so we'll think of this as not actually the weather, but what someone's using to make some tea.
Mr. Pressure, imagine if you're that sick.
Okay, no, I would rather not.
You'd be dead.
You'd be dead. Okay, a little scattered here. Let's try to be focused. Okay, let's not spend a lot of time fielding a bunch of random stuff. Okay, 25% of 2,000 is 1/4 of it is 500, or reduced by 25% would be 1,500. Increased by 2,500. Thank you. I'll owe you a focus point over there. Then, yeah, this might look a little bit more complicated than it actually is. Well, first of all, when they say which pyramid has 5 faces and 5 vertices, is the answer is the pyramids of Giza?
Yeah, it is. Well,
But that's not really what they're asking.
It is
is
technically.
it? Technically, you'd be true, but mathematically, you'd be incorrect. What is the name of the type of pyramid that would have that? Yes, sir?
Pyramid.
No. Let's be a little bit more specific. What type of pyramid would have the 5? Oh, come on. The other class is totally blurring this at me. What?
Rectangular prism.
Oh, very close. But it is a type of rectangle.
Square pyramid.
A square pyramid. Yes. Yep.
It's literally called
square pyramid.
I put pyramid with square base.
Okay, no, you're right, but it's called a square pyramid. Square pyramid. Okay. Okay. All right, start with 2 dozen plus 1 times 4 plus 20. Moving along. Divided by 3, unless I made some mistake. Or unless you're trying to get me to make a mistake. 42 divided by 6, 7 times 4, 28. I'd appreciate if you didn't talk over while I'm doing this. Thank you. 28 minus 3 is 25. Unless I've actually made a mistake, in which case do feel free to stop me. Square root is 5. Then divided by 2 is just 2.5. Just doesn't seem that satisfying, does it? Oh, I know. You know, and I was so excited this morning because I had it so that the times 4 was cut off, and it comes out to 1 exactly if you do that. So I was like, 1, yeah. And then so I was like, Mr. Pretry, in the book there's a times 4. I'm like, oh.
That's so sad.
So yeah, double yours. Okay. Anyway, now I'm the one slowing us down. All right. So moving along, applications of the Pythagorean Theorem. Sorry, I'm having a little trouble talking today. The first one, they don't really explain context to this too well, but here's the idea, and it's actually very, very simple idea they're trying to get across here. All right, so say you've got this triangle. And the triangle's dimensions are like that, right? And we would call this a Pythagorean triplet because these do, in fact, add up to 5 square. So basically, it is such that 5 square plus 12 square does equal 13 square. So, wonderful. So that's a triplet. And so what the next stage here is they're imagining a little bit of scale factor going on. So say we were to do another one, and we were to put that one at a scale factor of 2.
That has perfect proportions.
Yeah, I know. I'm actually quite proud of it. Thank you. I'm actually very proud of that. So if we're doing a scale of times 2, then and we know that all of these are going to work in the Pythagorean theorem, then we can just do what to figure out the sides for each of these now? Yes.
Multiply by 2.
Yeah. So. Okay, da-da. And so when they're saying what are the next 3 multiples of this Pythagorean triplet, basically our first scale up is 10, 24, 26, right? So I'm going to give you a moment to figure out what would be the next 2 multiples of the triplet. If we're doing 3 of these and this is 1, what are the other 2?
If what's 1?
So this is number 1. It wants for you to do 3 of these. So number 2.
Also just any 3?
No, the next 3 in the sequence.
Oh.
So, okay, I'm going to take one deep breath and see if you can solve this mathematical riddle. So, spoilers, our next one would have a scale factor of 3 instead of 2. Right? Because this is number 1 of your next sequence. So, you multiply each one by 3. And then you would multiply the next one by
4.
Okay.
Oh God.
Ta-da! Okay, that's it here.
That's it.
That's it. I know.
Wow.
Right, not very satisfying.
Wait, this is insulting in a way.
I think they forgot the. They might not have put this in the lesson, but another application would be the one where you're on a grid.
Uh-huh.
There's a line segment, and you can calculate it by taking 2 points.
Oh, there you go.
Points, and then
Okay, right on. Cool. They didn't actually even include this application. I figured out this is probably the application for it. Nope. They just said the number sequences. So I was like, maybe give this a little bit of context, because otherwise it says, hey kids, look at these numbers. Yep, there they are. Okay. All right, so here we're getting into a little bit of real world, a little sciencey, craftsmanship. I like the idea of this, but the only problem with it is once you get to the point where you have to get the square root, you would need a calculator. Which I think they really could have designed a problem better where you could just figure it all out yourself without having it being spoon-fed to you. So when you get to the part where you need to do like the ultimate square rootage, then just stop there and I'll just give that to you. Okay, but that being said, a roof being built over a 24-foot wide room. The slope of the roof is 4 inches.
What's it 12 for?
Oh, did I cut off here? Let's see. It's 4 and 12. Excuse me, that's not an inch sign. Is 4 in 12. So they're trying out the scale factor of this, and so what they're saying is that you've got like a 4 rise and a 12 run, but really the important part of this is once you have this information. What you are trying to include is, what is the length of the rafter going to be? So that question is there. Here, maybe I'll change colors here.
Are the rafter tails combined too? Or just
No, just so the length of one rafter. That is also a little misleading, isn't it? So essentially, you just need to use the Pythagorean Theorem to figure out what is the length of that upside down hypotenuse. Okay, so I will give you a moment. It appears that the 24-foot wide room thing is useless information.
that's gonna be a difficult for.
Oh, well, don't try to do it yourself. It's okay. Room 16. I have my own color printer in the room. Yes. I do not. Bye. Okay, so I'm sure that gave everyone plenty of time to start figuring this out. Alright, so, this is a pretty straightforward of, this A, this B, this C, and a squared plus b squared equals c squared. Or, in this case, we can start plugging in our numbers. And say 4 foot squared plus 12 foot squared is going to equal c squared. So that's what our step here is to figure out what is the length of c. Also, don't forget that we will need to include 2 feet at the end of what we're doing. So doing those out, got 16 square feet plus 144 square feet still equals c squared.
They couldn't have just made it a little more satisfying and multiplied everything by 10 or something.
I somehow feel like they could have done this so that we didn't need any help getting the square
Like,
root.
could they make it 1600 instead of 160?
Yeah. I just kind of feel like they could have made it so you could have completely done it yourself, and then that would be quite a bit more satisfying, wouldn't it? Okay, so we're to there. And then, of course, we need to get the square root of each one. In order for that to work, but that's kind of not too cool to do without a calculator. So, ka-ching! I'll just give that to you. All right, so we'll get it to, it's about 12 and 65 hundredths feet equals C. Now, another thing that's a little bit unsatisfying at this point is, now, would we typically say 12 and 65 hundredths of a feet? That would make a lot more sense with the metric system, because you could easily look at that and go, oh, well, let's say if it was 12 and 65 hundredths meters, then I could easily just go, okay, well, then that's 12 meters and 65 centimeters, no problem. But with this, I'm just kind of looking at it going, well, it's a little bit more than half a foot. That's about what I can tell from that. Oh, and by the way, sorry. About, not equal to. Just we rounded it. Okay, so let's figure out turning that into something we can use a little bit easier. So we can do a unit multiplier and say 65 hundredths of a foot, I'll say over 1, is equal to unit multiplier of 12 inches to 1 foot. Do a little bit of cross cancelly goodness, and you could multiply that out. I'll just do spoilers here. It comes out to 7 8/10 inches. Okay, so we could say that 12 feet, 7 8/10 inches. See, what's even more unsatisfying about this is even after making us do the conversion from decimal feet to inches, we still wind up with a decimal in our inches.
I know, it's so unsatisfying.
It is deeply unsatisfying the way this has been presented.
It's a sacrilege.
Yeah. And what have I forgotten?
Oh,
Yes.
the length of the Rafter deal.
Yes. We need to add the 2 feet. 14 feet, 7.8 inches, about.
Tiny roof. Really tiny roof.
Yeah. So, more of a shed, really, right?
Yeah, maybe the shed.
Okay.
Definitely.
So, moving along. Serena.
Oh,
Now, we had fun with this because she was not here this morning.
Oh.
So, we basically played it out like what? Serena isn't here because she's on a field flying a kite. Anyway, yeah. So, Serena went to a level field this morning during math class to fly a kite. No, that wasn't right. She wasn't there. Anyway, she let out all 200 feet of string and tied it to a stake. Yes, stake. It's a wooden thing you put in the ground. No, not a steak you eat. Okay, not a steak you eat. All right. A pole that's been stuck in the ground kind of stake. Spelled differently than the other stake. Moving along then. Then she walked out on the field until she was directly under the kite 150 feet from the stick. So there's her string. There's her forward motion. We're trying to figure out the height. Okay, so knowing what you know, see how far you can get along in figuring out.
Okay,
See how far you can get. Let's give it 3 minutes to see if you can figure this out yourself. I'm going to time about 3 minutes. I mean, it shouldn't be too hard to figure out the square root. You might need a couple of, do a little bit of trial and error.
It's pretty simple. Not that much.
Yeah, I mean, you might have to try a couple things to figure out what the square root is, but maybe I'll do a little basic problem setting up. Maybe I hope people catch something. Okay, so we'll think that's A, that's B, and that's your C.
There are only 2
So-
bastards. Yeah, I know.
Please do not try to have this discussion right now. Okay, so we know we're going that formula.
it would have been satisfying if the height was 200.
All right. And so, writing out on our equation, we'd be starting out. And okay, so that's what you're working with. I'll stop for a little bit. What you did further. Soon we've gotten that a little farther. Oops, that should have been squared. Excuse me. Doing that out. 3 feet. Uh-oh. Do I even have room here? Okay. Okay, and then your next step is to subtract this from each side. Which will get you to a squared equals 1,700. And then, now here's the tricky part. The square root each side. So I'm gonna stop for a minute, but in a moment I'm going to check in with someone and maybe a couple people, see what their particular method was.
You could separate it. You could use prime factorization.
Oh, okay. So there we go. That's sort of what I was fishing for. So okay. So we've got. So we've got this number, and we're trying to figure out what the square root is, right? Oh, but not that one. Hey, sorry. We have that number. and we want to figure out what the square root is. So you said prime factorization. What'd you factor out?
Prime factorization could be good. Okay, I just did a simple like it was a long prime factor. Actually no, I did it in my head, but you could do it prime factorization.
Okay, I'm just trying to get some steps here. How you went about this?
You could divide it by 10 or 5 first.
Divide by 5 first.
Or no, sorry, 2 first.
Divide by 2 first.
Okay.
Okay, which would get me just help me out here.
7,000.
That's divided by 2.
Oh wait, no, sorry, wait. Oh no, 8,000. 250.
Okay. So you divide by 2.
Wait, I thought you were supposed to make a calculation.
Is that what we were doing?
Yeah.
Okay. I'm not sure I have room for that, actually.
You could use a blank page.
Okay. Okay, 17,500. Okay, it's turning in a little bit more of a sync than I thought. And then, okay, so sorry. All right, 2 times.
8,250.
Okay.
You could divide that by 2 again, and you get 4,120.
It's 8,700. Yeah.
Can't you divide it by 5?
Okay.
Never mind. Then you get 2,375.
Wait, where?
Or no, sorry, 4,375.
So, one more time.
4,375.
Okay.
And then you could divide that by 5.
Okay.
And you would get 260. And then you would get, you get 275.
Okay.
Okay, and then you could divide it by 5 yet again. And then you'd get 30. 35, I think.
Yeah. No.
Or no, then what? 30 something.
No, it's 30.
Okay, it's 14. Oh,
It's 55.
yeah, it's 35.
It's 55.
Yeah, 55, sorry, 55. Sorry. Okay.
Yeah. 55.
Divide 5 and 11.
Okay. Yay! All right, so we got that out. Now what?
Okay, and then you need some okay, so I think you can like factor out ones, like remove 1, 2. Remove okay, that's pretty much all.
So was this going to get us towards the square root?
No.
No? Okay, great use of screen time there, sir. All right, but you got the correct, I saw you got the correct square root.
Yeah, no, it's because I literally went through every number.
Okay, you literally went through every number.
Yeah, I brute forced it.
So what you did was you tried a few things and one of them worked.
Yes. No,
Could you have led with that perhaps, sir?
No, I estimated something that was close to that. And then
Right, and okay, so that is actually probably the more correct way to do it than whatever that was trip we just got taken along on. Is you try to guess something that might be close to that. So did anyone else get it correct? Anyone else get the square root of this? Oh. Okay, so basically, yeah, we're way over time here. So essentially, getting the square root of that, you basically do a little guessing. Try something, see how close you are to it.
You can start with 150, by the way.
Yeah, start with something like 150. You do that one, and you're like, oh, I'm way over. So I had better try something a little bit lower, and so then maybe you go down to 130 and go, hey, I'm just a little bit over now. So maybe we'll try just changing that a little bit. We'll try like 131. Nope, that didn't work. Oh, 132 did work. So yeah, finding the square root. It's really probably the best way to go about it is make a guess, see how close that guess is, and keep on using that information to guess your way closer to the correct answer. Okay.
3.